In this question, the unit vector I is a horizontal and the unit vector j is vertically upwards. A particle mass of 0. kilograms moves under the action of its weight and two forces given by 3I plus 5j newtons and ki plus 4j newtons. The acceleration of the particle is vertically upwards. Find the value of k. Initially, the velocity of the particle is 5I plus 3j meters per second. Find the magnitude of the velocity of the particle 8 seconds later. Okay, important to try and draw a diagram. So here's my particle. So we have a force of minus 0.8 GJ acting downwards. We have this one which is 3I and 5J, newtons acting that way. And we have this one which is Ki plus 4J. So as the particle is moving vertically upwards, let's put the acceleration in. We have we can resolve this way, all right, and as it's going upwards, we will have to say that the I components must balance each other out, and therefore 3 minus k must be 0, k is equal to 3. Okay, drawing our diagram again. If we now resolve vertically, so using Newton's second law, which is F is equal to ma, we will have 5, just losing the j components, 5 plus 4, so 5 plus 4 minus 0.8 g must be equal to the mass times the acceleration, so that acceleration will be 9 minus 0.8 g divided by 0.8, which will give 1.45 meters per second squared. Therefore, the vector quantity will be 1.45 j meters per second squared. There is no component this way. So if we now use the final velocity, vector velocity is equal to the initial vector velocity plus the acceleration vector times time. So that will give that v will be the initial velocity, which is 5I plus 3j, plus my acceleration, which is 1.45j, times my time, which is 8. So that will give 5I plus 3j is plus 11.6j. We do 8 times that. Let's write that out again. Adding together the j components, that will give 5I plus 14.6j as a vector. We want the magnitude, so that will be 5 squared plus 14.6 squared, which will give me 15.43 or 15.4 meters per second. So this has been a video to show you how to find the acceleration for a system suspended by two forces and its weight. I hope you've understood, and I thank you very much for watching.